Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome back to Group 3. In this video, we will talk about salt hydrolysis. But before we discuss about salt hydrolysis, let me introduce Group of 3. Here I am, Vedra Sandrina Manalu, as presenter of Group 3. But in this video, I'm not alone. I'm with my friend. There are Azizah Permata Sari, Fatikha Khoirinisa, Soni Enembe, sang Ayu Putu Adelia, and Dinda Arsyta. At first, I'm going to talk a little bit about salt hydrolysis. Salt hydrolysis. It is characterized as the reaction of the cation or anion of the salt with water to create either an acidic or basic solution. On the basis of the relative strength of acid and base produced due to hydrolysis, salts are classified into 4 classes, and the classification will be discussed by my colleague. So, listen to it.
My name is Fatikha Khoirinisa with NPM 221-302-3025. I will continue my friend's explanation. Salt of strong acid and strong base. Salts such as KCl, NaNO3, NaCl, K2SO4, Na2SO4, and KNO3 are examples of salts formed from a strong acid and a strong base. When dissolved in water, the salts form strong electrolytes that separate cations and anions. These ions do not undergo hydrolysis, meaning they do not interact with water. As a result, there is no change in the concentration of H+ and OH- ions in solution. As a result, the resulting solution is neutral. An example of a reaction involving a salt, a strong base, and a strong acid is the reaction between sodium hydroxide, a strong base, and hydrochloric acid, a strong acid, to form sodium chloride salt and water. The balanced chemical equation for the reaction is: in this reaction, sodium hydroxide reacts with hydrochloric acid to produce sodium chloride and water. Sodium chloride is a salt formed by the combination of cation, sodium from the base, and an anion chloride from the acid. Salts of weak acid and strong base. Salt such as CH3CONA, Na2CO3, K2CO3, and Na3PO4 and others are examples of salts from a weak acid and a strong base. When the salts are dissolved in water, they undergo hydrolysis, resulting in the formation of a weak acid and a strong base. An example of a salt from a weak acid and a strong base is sodium acetate. Acetic acid is a weak acid, while sodium hydroxide is a strong base. When these two compounds react, the acetic acid donates a proton to the hydroxide ion, forming water. The remaining sodium ion from the base combines with the acetate ion from the acid to form sodium acetate. Sodium acetate is salt that dissociates completely in water, yielding sodium ions and acetate ions. It is often used as a food additive and in various chemical and industrial applications.
My name is Azizah Permata Sari, NPM 2213023024. Salt of strong acid and weak base. Salt formed from a strong acid and weak base are known as acidic salts. When a strong acid reacts with a weak base, the resulting salt will have acidic properties. Resulting salt will have acidic properties because the anion deviates from the acid is not completely neutralized by the cation derived from the weak base. As a result, the anion of the salt can act as weak base and can accept a proton H+ from water, leading to the formation of hydronium ions H3O+. Example of salts formed from a strong acid and weak base: ammonium chloride and aluminium sulfate. 5. Salt of weak acid and weak base: NH4, 2CO3, CHCONH. Attention are the example of the salt of weak acid and weak base. On treating this salt with water produce parent weak acid and weak base. Example: thus it involves first. Example: thus involves both cationic and anionic hydrolysis. The resulting solution may neutral or slightly acid or basic depending upon the relative degrees of cation of the weak acid and the weak base produced.
Hello, my name is Soni Enembe with NPM 2213023043. Solubility products: salt like AgSO, CaSO4, PbSO4, PbCl2, etc. are considered as insoluble salt, but no salt is absolutely insoluble in water, i.e., they dissolve slightly in water, so they are called sparingly soluble salts. If a sparingly soluble salt like AgSO is stirred in water, it dissolves in water to a very small extent and forms the saturated condition. The ions in the solution collide and reproduce solid phase. Ultimately, a dynamic equilibrium is established between the solute and ions in the solution. Depending upon the value of ionic product, a solution may be either unsaturated, saturated, or supersaturated. 1. If ionic product EAP case B, the solution is said to be unsaturated, it can dissolve more solute at given temperature. 2. If ionic product AP case B, the solution is said to be saturated. If ionic products EAP case B, the solution is said to be supersaturated and precipitation of the salt takes place. By comparing the value of ionic products with solubility products, it is possible to predict whether precipitation will occur or not when two solutions containing common ions are mixed together. If ionic product is greater than the solubility product, then precipitation will take place, otherwise not. This principle is called theory of precipitation or solubility product principle.
Introduce myself, my name is Putu Adelia. Well, here I will continue the material about relation between solubility and solubility product. Solubility is related to solubility product. Solubility is the number of grams of substance dissolved in 100 grams of solvent to form a saturated solution at a given temperature. Solubility can occur for all dissolved substances, both electrolytes and non-electrolytes. However, the solubility product is only applied to slightly soluble electrolyte solution. The solubility of electrolytes can be reduced by the addition of another electrolyte having the same ions, while the temperature is constant, but the solubility product remains constant even when the electrolyte has the same ions added. It is known that by Solubility as well. The solubility product increase with increasing temperature.
Permission to introduce myself. My name is Dinda Arsyta Swandy with the MPM 221302380. Here I will explain the material about difference between ionic product and solubility product. The terms ionic product and solubility product are both related to the concept of equilibrium in chemical reactions, particularly in the context of dissolution and precipitation of salts. While they are similar, there is key distinction between them. Ionic product. The ionic product refers to the product of the concentrations or activities of the ions in a solution when a sparingly soluble salt is dissolved. It's denoted by the symbol Q and is similar to the concept of reaction in chemical equilibrium. The ionic product helps determine whether a given solution is saturated in with respect to the dissolution or precipitation of salt. Next, the solubility product, on the other hand, is a specific type of ionic product. It refers to the equilibrium constant for the dissolution or precipitation of a sparingly soluble salt in a saturated solution. It's denoted by the symbol KSP and represents the product of the concentrations or activities of the constituent ions right to their stoichiometric coefficients in the balanced chemical equation for the dissolution or precipitation reaction. To summarize, the ionic product is a general term that refers to the product of the concentrations in a solution, whereas the solubility product is a specific term that represents the equilibrium constant for the dissolution or precipitation of a sparingly soluble salt.
So that's all the presentation from Group 3. I hope those of you who watch this video can understand about salt hydrolysis. Sorry if there is a mistake. Thank you for watching and see you guys!